Good morning, Cary High. My name is James Auwn, and about 5 years ago, I was also a AP Research student in Mr. Jesse's class. Today, I'm in Montreal, Quebec, and I'm in a neuroscience fellowship at McGill University. A little bit of what I want to talk about and get from this experience as a Reach the World traveler, this is how I'm kind of corresponding to you right now, is to talk a little bit about the value of international collaboration, as well as how you can really take the most from this AP research class to propel you toward a career in research, in academia, or wherever you see yourself going. The skills in research are super, super applicable to really a wide array of personal, interpersonal, professional skills that can be really helpful wherever you go career-wise. But a little bit about myself. I am James Auwn. I went to Cary High School and graduated in 2020. I did this whole like AP research, AP seminar, curriculum track. Really loved that. I took the cool APs that you guys are probably having fun with right now, and it was great. I really loved Cary High School. I got a lot of the community, and now I find this a really fun and cool way to reconnect with one of my favorite teachers at the school, Mr. Jessee, as well as kind of talk to the new generation of AP researchers and see what's going on in your side of the world right now. Beyond my time at Cary High School, I attend Appalachian State University, where I major in molecular biology and psychology with a minor in chemistry. My whole kind of like mission in that is I want to study neuroscience and kind of looking at the molecular facets of it as well as the more cognitive behavioral facets of it are really important to understanding like the greater picture of neuroscience. And so that's why that molecular biology and psychology fusion really takes roots and has a gander with it. Beyond that, I do a lot of stuff at Appalachian State University. I volunteer a lot with chemistry club. I do chemical demonstrations. Maybe I'll show some cool stuff with that. I love hiking. I love playing guitar. Maybe we'll do a little concert sometime later on in the year. But something I also do and takes a lot of my time is research. I study the genetic factors that contribute to the way that neurons develop and how the way that neurons develop can affect how we perceive and sense and process pain. And so that's what I do at Appalachian State University. But as I continue to research and do more work in that field, the field is called nociception, which is the perception of noxious stimuli. The more I did work in that field, the more I wanted to expand my investigative toolbox and see more perspectives on how pain research or nociception research is conducted. And so I applied for this Fulbright MyTax grant. It's a great opportunity once you get to undergrad to conduct a bunch of different type of research topics in Canada. And great funding, great experience that I had. And I went to Queen's University, which is in Kingston, Ontario. It's right on the Lake Ontario, and so I got to jump into the lake, have some fun swimming time there. But more than that, I got to do research at Queen's University, which is in Kingston, Ontario. And at Queen's University, my whole project was looking at not the genetic factors, but more how the electrical components of neurons, the way that they communicate with one another, and how they generate these electrical signals to communicate with one another, plays a role in how they sense, detect, and then send signals to the brain of signals of pain. And so I did a lot of different experiments looking at how Lyme disease is that disease that you get from ticks, how that can sensitize the neurons in our body and make us feel more painful signals, but also have a higher propensity to detect these signals and send those to the brain. As I was studying this project at Queen's University, I was exposed to a lot of concepts that made me interested in neuroplasticity, because how neuroplasticity works in like a very rudimentary way is that the more signals that our brain receives, the higher the chance or rate at which it will form a stronger or more developed neural pathway that's related to those signals. And so with pain, that's obviously really relevant because if something makes us more sensitive to pain or makes us have stronger pain stimulus, say pain sensations, then that can affect the way that our brain processes these signals and could make it so that our brain processes these signals more readily. And so obviously that's pretty bad for folks that are suffering from pain every day. And so when I was invited to do research at McGill, to study neuroplasticity, it was kind of a no-brainer that I would kind of transition into that research position. And so now I'm on a grant called the Gilman Scholarship, Benjamin A. Gilman Scholarship. It's another fantastic award for folks in undergraduate to fund their study or research experiences abroad. And so I'm using this award to study in Montreal, Quebec at McGill University under the supervision of Dr. Hoystrom. What I do in the lab with Dr. Hoystrom is similarly, I'm looking at like how the electrical properties of neurons, and I do this, and I can show these images later on throughout our Reach the World collaboration. But how I do that is I take this really small pipette, and it honestly looks like a needle, and it's made of glass, and you make these yourself before you record each neuron. You put that really small glass tube in this machine, and it heats it up and then pulls it. And then you take these pipettes and you put them on a little manipulator, and you have one hand on the manipulator, you're spinning around, the thing goes in, you spin around, it goes out, and you approach a neuron with this pipette, and you touch it, and then you can release this like pressure that you have built up inside the pipette, and it'll suck the membrane of the neuron. Like the little cells have membranes through these like little like a balloon. It's like if you take a little like a suction, like a pipette, you bring that to a balloon, it would be similar to how we do those with the neurons. And so you literally will see a dimple where you've formed a suction in the neuron, and that's how you know that you've kind of attached your pipette onto the neuron. And then you literally use your mouth and you go, and you suck a little bit of negative pressure in, and it breaks the neurons, like almost like pops a little part of the balloon, which is like maybe an analogous way to explain the neuron. And you now form this little connection with your pipette to the inside of the neuron. And so now you can start to measure all sorts of cool properties of the neuron, like what's going on inside the neuron electrically, chemically. It's a really cool technique. It's called patch clamp. If you have the opportunity to learn about patch clamp or do it in undergrad, it's really fun. For folks that are really into like music or maybe video games, you might like this form of techniques because it's very involved. You're using your hands a lot. But that's what I do like most of the time, and I can show pictures of this throughout the course. And so that's kind of my general research mission right now, is to get better at doing patch clamp, to study pain, to study neuroplasticity. And specifically, actually, the project I'm working at McGill University is studying this drug called hydroxynorketamine. It's a big name, but really what it is it's a subform of the drug ketamine. And while ketamine has all these symptoms, like it makes you feel dissociated, and it reduces your ability to feel physical pain. It's being looked at a lot as like an antidepressant because it has really, really good antidepressant properties. But the subform of the drug, hydroxynorketamine, it doesn't kill your pain. It doesn't dissociate you. It just is antidepressant. And so it's a really awesome candidate, but folks don't really know how it works. And so what I'm doing is I'm using this patch clamp technique in conjunction with a lot of different experimental methods to elucidate, to find out how patch clamp can be used to figure out how hydroxynorketamine affects the way that neurons communicate with one another and form new pathways to neuroplasticity. I'm so excited to talk to you all more about my projects, what's going on in Montreal, what's going on in my life in general. It's always a pleasure to be collaborating with Mr. Jessee again, and I can also talk more about my own AP research project when I was a student at Cary High School. And so really excited for this partnership, and please just reach out to me if there is any way that you have any questions about stuff. But we're actually going to have a video call coming up this next week, and I'm really excited for that. So stay tuned, and I'm excited to see you guys then. Bye bye.